Hello everyone, welcome to Indian Clinical Radiological Physics Academy, and today we are going to know about the hidden history of the world's most famous picture taken in October 1927, 5th Solvay International Conference on Electrons and Photons, where the world's most notable physicists met to discuss the newly formulated quantum theory. 17 of the 29 attendees were, and Nobel Prize winners. It is pleasure to know their contributions in science and that made us to define the meaningful words before, and after them Albert Einstein. Einstein was a German-born theoretical physicist, who developed the theory of relativity, one of the two pillars of modern physics. His work is also known for its influence on the philosophy of science. He is best known to the general public for his mass-energy equivalence formula E=mc², which has been dubbed the world's most famous equation. He received the Nobel Prize in Physics for his discovery of the law of the photoelectric effect, a pivotal step in the development of quantum theory. Einstein published more than 300 scientific papers. Niels Bohr was a Danish physicist, who made foundational contributions to understanding atomic structure and quantum theory, for which he received the Nobel Prize in Physics in 1922. Bohr developed the Bohr model of the atom, in which he proposed that energy levels of electrons are discrete and that the electrons revolve in stable orbits around the atomic nucleus but can jump from one energy level to another. Louis de Broglie was a French physicist who made groundbreaking contributions to quantum theory. He postulated the wave nature of electrons and suggested that all matter has wave properties. This concept is known as the de Broglie hypothesis, an example of wave-particle duality, and forms a central part of the theory of quantum mechanics. De Broglie won the Nobel Prize for Physics in 1929. William Lawrence Bragg was an Australian-born British physicist and X-ray crystallographer, discoverer of Bragg's law of X-ray diffraction, which is basic for the determination of crystal structure. He was joint winner with his father, William Henry Bragg, of the Nobel Prize in Physics in 1915. For their services in the analysis of crystal structure by means of X-ray, an important step in the development of X-ray crystallography. As of 2019, he is the youngest ever Nobel laureate in physics, having received the award at the age of 25 years. Arthur Compton was an American physicist who won the Nobel Prize in Physics in 1927 for his discovery of the Compton effect, which demonstrated the particle nature of electromagnetic radiation. In 1922, he found that X-ray quanta scattered by free electrons had longer wavelengths and, in accordance with Planck's relation, less energy than the incoming X-rays, the surplus energy having been transferred to the electrons. This discovery, known as the Compton effect, demonstrated the particle concept of electromagnetic radiation. NASA's Compton Gamma Ray Observatory was named in honor of Compton. Marie Sklodowska-Curie was a French physicist and chemist who conducted pioneering research on radioactivity. She was the first woman to win a Nobel Prize, the first person and only woman to win twice, the only person to win the Nobel Prize in two different sciences, and was part of the Curie family legacy of 5 Nobel Prizes. She was also the first woman to become a professor at the University of Paris. Her achievements included the development of the theory of radioactivity, techniques for isolating radioactive isotopes, and the discovery of the two elements, polonium and radium. Element curium was named after Curie. Max Planck was a German theoretical physicist whose discovery of energy quanta won him the Nobel Prize in Physics in 1918. In 1894, Planck turned his attention to the problem of black-body radiation. How does the intensity of the electromagnetic radiation emitted by a black body depend on the frequency of the radiation and the temperature of the body? The question had been explored experimentally, but no theoretical treatment agreed with experimental values. The central assumption behind his derivation is that electromagnetic energy could be emitted only in quantized form. In other words, the energy could only be a multiple of an elementary unit, E=h², where h is Planck's constant. Hendrik Lorentz was a Dutch physicist who shared the 1902 Nobel Prize in Physics with Peter Zeeman for the discovery and theoretical explanation of the Zeeman effect. He also derived the transformation equations underpinning Albert Einstein's theory of special relativity. Lorentz theorized that atoms might consist of charged particles and suggested that the oscillations of these charged particles were the source of light. Local time Lorentz's most ingenious idea, and illustrated it by showing that clocks in moving frames are synchronized by exchanging light signals that are assumed to travel at the same speed against and with the motion of the frame, which is Einstein's synchronization and relativity of simultaneity. Erwin Schrödinger. Schrödinger was a Nobel Prize-winning Austrian physicist who developed a number of fundamental results in the field of quantum theory. The Schrödinger equation provides a way to calculate the wave function of a system and how it changes dynamically in time. He is also known for his Schrödinger's cat thought experiment. A cat, a flask of poison, and a radioactive source are placed in a sealed box. If an internal monitor, Geiger counter, detects radioactivity, a single atom decaying, the flask is shattered, releasing the poison, which kills the cat. The Copenhagen interpretation of quantum mechanics implies that after a while, the cat is simultaneously alive and dead. Yet, when one looks in the box, one sees the cat either alive or dead, not both alive and dead. This poses the question of when exactly quantum superposition ends and reality collapses into one possibility or the other. Wolfgang Pauli. Pauli was an Austrian-born Swiss and American theoretical physicist and one of the pioneers of quantum physics. Pauli received the Nobel Prize in Physics for his decisive contribution through his discovery of a new law of nature, the exclusion principle. That discovery involved spin theory, which is the basis of a theory of the structure of matter. The Pauli's exclusion principle is the quantum mechanical principle which states that two or more identical fermions, particles with half-integer spin, cannot occupy the same quantum state within a quantum system simultaneously. For example, if two electrons reside in the same orbital, and if their principal quantum number, the angular momentum quantum number, magnetic quantum number values are the same, then their spin quantum number must be different, and thus the electrons must have opposite half-integer spin projections. Werner Heisenberg. Heisenberg was a German theoretical physicist and one of the key pioneers of quantum mechanics. He is known for the Heisenberg uncertainty principle, which he published in 1927. He was awarded the 1932 Nobel Prize in Physics for the creation of quantum mechanics. Heisenberg uncertainty principle states that the position and the velocity of an object cannot both be measured exactly, at the same time, even in theory. The very concepts of exact position and exact velocity together, in fact, have no meaning in nature. Peter Debye. Debye was a Dutch-American physicist and physical chemist, and Nobel laureate in chemistry. His first major scientific contribution was the application of the concept of dipole moment to the charge distribution in asymmetric molecules, developing equations relating dipole moments to temperature and dielectric constant. He extended Albert Einstein's theory of specific heat to lower temperatures as the Debye model. Debye calculated the effect of temperature on X-ray diffraction patterns of crystalline solids. He developed an improvement over in his theory of electrical conductivity in electrolyte solutions. Paul Dirac. Paul Dirac was an English theoretical physicist who is regarded as one of the most significant physicists of the 20th century. Dirac made fundamental contributions to the early development of both quantum mechanics and quantum electrodynamics. Dirac shared the Nobel Prize in Physics with Erwin Schrödinger for the discovery of new productive forms of atomic theory. He formulated the Dirac equation, which describes the behavior of fermions and predicted the existence of antimatter. For every 10 billion antiprotons present in the early universe, there were 10 billion and 1 protons. That tiny imbalance formed the matter-filled universe we know today. Paul Langevin. Langevin was a prominent French physicist who developed Langevin dynamics and the Langevin equation. The original Langevin equation describes Brownian motion, the apparently random movement of a particle in a fluid due to collisions with the molecules of the fluid. He is also famous for his ultrasonic submarine detection. Irving Langmuir. Langmuir was an American chemist and physicist, He was awarded the Nobel Prize in Chemistry in 1932 for his work in surface chemistry. Langmuir's most famous publication is the article The Arrangement of Electrons in Atoms and Molecules Chemical Bonding Theory, in which he outlined his concentric theory of atomic structure. Langmuir advanced several fields of physics and chemistry, and he invented the gas-filled incandescent lamp and the hydrogen welding technique. Charles Eugene Guy. Guy was a Swiss physicist. His research focus was in the fields of electric currents, magnetism, and electrical discharges in gases. He conducted experiments that demonstrated the dependence of the electron mass on its speed, with results supporting the predictions of Lorentz, Einstein, and the special theory of relativity. Charles Thomson Rees Wilson. Wilson was a Scottish physicist and meteorologist who won the Nobel Prize in Physics for his invention of the cloud chamber. The Cavendish Laboratory praised him for the creation of a novel and striking method of investigating the properties of ionized gases. The cloud chamber allowed huge experimental leaps forward in the study of subatomic particles and the field of particle physics, including X-rays, ionization, thundercloud formation. Owen Willens Richardson. Richardson was a British physicist who won the Nobel Prize in Physics in 1928 for his work on thermionic emission, which led to Richardson's law. He demonstrated that the current from a heated wire seemed to depend exponentially on the temperature of the wire. Richardson's law states that the emission current density is exponentially depend on work function and inversely depends upon the absolute temperature. This process is crucially important in the production of X-rays for imaging and radiation therapy. Max Born. Max Born was a German physicist and mathematician who was instrumental in the development of quantum mechanics. He also made contributions to solid-state physics and optics. Born won the 1954 Nobel Prize in Physics for his fundamental research in quantum mechanics, especially in the statistical interpretation of the wave function. A chance meeting with Fritz Haber in Berlin in 1918 led to discussion of the manner in which an ionic compound is formed when a metal reacts with a halogen, which is today known as the Born-Haber cycle. Martin Knudsen. Martin Knudsen was a Danish physicist. He is primarily known for his study of molecular gas flow and the development of the Knudsen cell, which is a primary component of molecular beam epitaxy systems. Hans Kramers. Kramers was a Dutch physicist who worked with Niels Bohr to understand how electromagnetic waves interact with matter. In 1925, with Werner Heisenberg, he developed the Kramers-Heisenberg dispersion formula, and it was an important achievement when it was published, explaining the motion of negative absorption, stimulated emission, and inelastic scattering, where the energy of the scattered photon may be larger or smaller than that of the incident photon, thereby anticipating the Raman effect. Auguste Piccard. Auguste was a Swiss physicist, inventor and explorer, known for his record-breaking helium-filled balloon flights, with which he studied the Earth's upper atmosphere. Auguste was also known for his invention of the first bathyscape, with which he made a number of unmanned dives to explore the ocean's depths. He is the first man to witness the curvature of the Earth with his own eyes during a balloon flight in 1931. Emile Henriette. Henriette was a French chemist notable for being the first to show definitely that potassium and rubidium are naturally radioactive. He investigated methods to generate extremely high angular velocities, and found that suitably placed air jets can be used to spin tops at very high speeds. This technique was later used to construct ultracentrifuges. He was a pioneer in the study of the electron microscope. Paul Ehrenfest. Ehrenfest was an Austrian and Dutch theoretical physicist, who made major contributions to the field of statistical mechanics and its relations with quantum mechanics, including the theory of phase transition and the Ehrenfest theorem, which relates the time derivative of the expectation values of the position and momentum operators. Edouard Hertzen. Edward was a Belgian chemist of Russian descent who played a leading role in the development of physics and chemistry during the 20th century. He collaborated with industrialist Ernest Solvay, and participated in the first, second, fourth, fifth, sixth and seventh Solvay conferences. Théophile Dedander. Dedander was a Belgian mathematician and physicist famous for his work in developing correlations between the Newtonian concept of chemical affinity and the Gibbsian concept of free energy. He is considered the father of thermodynamics of irreversible processes. Jules, Emile, Schaeffer. Schaeffer was a Belgian physicist. He worked at Kamerlinghen's laboratory in Leiden from 1894 to 1906 and once again from 1914 to 1923. From 1906 to 1914 he worked at the Vrije University Brussels and from 1923 to 1940 at the Ghent University. Ralph H. Fowler. Fowler was a British physicist and astronomer. He worked on anti-aircraft ballistics. He made a major contribution on the aerodynamics of spinning shells. He became research supervisor to Paul Dirac and, in 1926, worked with him on the statistical mechanics of white dwarf stars. He helped to establish the validity of modern electron band theory. In 1931, he was the first to formulate and label the zeroth law of thermodynamics. He was awarded the Order of the British Empire in 1918. Léon Brillouin. Brillouin was a French physicist. He made contributions to quantum mechanics, radio wave propagation in the atmosphere, solid-state physics, and information theory. Brillouin was the founder of modern solid-state physics, for which he discovered, among other things, Brillouin zones. He applied information theory to physics and the design of computers and coined the concept of negentropy to demonstrate the similarity between entropy and information. Thank you for watching. To know more about interesting things, do subscribe.